Hello and welcome to this Manufacturing Systems Technology Module 42. Quick recap of what we were doing. We were trying to write an NC code for the particular situation shown in this question, where there is a slot milling operation carried out and an L slot needs to be developed in a block which has been given as 3 cross 2.5 cross 0.75 inches, and also it was there are certain assumptions that have been made, including where is the location of the program 0, which is at the lower left top corner of the block surface. It is assumed that when the tool starts moving, it is about 1/4 of an inch or 1/4 of an inch above the top surface prior to start of machining. So you have to position the tool from probably this corner all the way to somewhere here where the start of the machining process would happen, but you have to ensure that the tool is about 1/4 of an inch above that particular process, and only one pass is needed. So therefore it's assumed that the cutter size is of the same dia as the slot size, which is about 1/2 inches. We also have cutting speeds, feeds and machine specifications given. So we started writing this program, and we had covered up issues related to the start of the program depicted by percentage, which is the special character. Then we started writing 3 different lines, one where specification of or one which specifies the absolute dimensions to be followed. That means the reading would be only with reference to the origin every time. We also talked about the G command, which is needed for the particular system of measurements in progress. It's inches, so FPS system is used here. So inches units for describing the length units. We also were able to describe the speed in RPM and the feed in units per millimeter or per minute using the commands G97 and G94, and selected the tool as tool number 1. Okay, and then finally rapidly positioned the tool to the start point using the command G00, and I already described how we obtained these coordinates. Z plus 250 means 0.25 inches above the surface. The specification, mind you, is about x, y, z plus minus 4,3. Okay, so in that ambit, this represents actually the decimal is represented to the 3rd place, and then there are 4 zeros which are immaterial even if you don't write them. So that's why you're describing the z as 250 and positive because it is moving away from the tool. So you're having the tool going up from the surface 1/4 of an inch, and that's where the docking position of the tool is as represented in the question. So once this happens, now we are ready to start the machining. So we write the next line of the program N020 here, which describes the linear positioning. So obviously we use the G code G01 now, because now obviously the slot milling operation would start to happen, and it has to be happening at a slow manner with a certain feed rate which has been specified in the particular machining conditions. So you start with that, and then first thing you have to go is you don't really need to change the x and the y positions. So even if you don't write them in these particular steps, it's obvious it's taken as the previous x and y positions because they are modal commands. Unless you actually change them, they're not going to get changed by themselves. So basically all the change that happens here is only in the z direction, because you were placed 1/4 of an inch above the surface at the machining center, and you're now going to go down, and you're going to go down from the surface up to an extent of about 0.375 inches, as has been seen here in this specification here. So the milling slot depth is given here in the side view as 0.375 inches. So obviously now you have to make a choice, because it's an absolute dimensioning system, and you're assuming that this whole plane here on the surface of the particular block is treated to be the 0 plane, or at least the plane which is containing the origin. Therefore we are more concerned with how the tool would go below the 0 plane. So below this is the 0 plane, therefore the top side of the block, and you're going in the negative z direction, and you're traversing 0.375 inches. That's how the tool has to traverse. We're assuming the tool thickness to be very negligible in comparison to the dimensions that is being traversed, although there is there is a thickness of the the slot miller or slot cutter, which has to be accommodated here, but we're just neglecting at this particular point of time. So we write Z minus 375. Okay. So minus 375 obviously indicates that the tool now has to go from position quarter of an inch, that is 0.25 inches, to the position minus 0.375 inches. Mind you, again it's an absolute system of dimensions. We are recording the coordinates only from the origin, and the earlier coordinate, a quarter of an inch, was with respect to the origin, and this coordinate minus 0.375 inches also is with respect to the origin. So this is something that mostly the programmers make a mistake. So you have to be very, very careful you're writing, because it's an absolute system. Obviously you can use the miscellaneous command M03 to illustrate that it switches on the spindle, and M03 probably indicates that the spindle starts moving in the clockwise direction. You can also give a speed at this particular point to the rotating tool. The speed was given to be 500 RPM. Obviously the RPM has been described earlier here, as you can see by the code G97. So we are left with S500, which is the speed of the tool. And now you also can give a feed rate. Obviously there was no feed rate when you're talking about the rapid positioning, because the feed rate would be defined by the shortest possible time path that the tool would take, as I had described in great details earlier. So here this feed rate is given again in units per minute, and it's about 10 inches per minute. So I just write F10 here as my the whole command block. And so this command block basically indicates what all. It turns on the spindle, it feeds the tool to the required depth, at the feed rate indicated, and then obviously it turns on the spindle at a certain speed and actually lets it go to up to the 500 RPM speed. So now it's all set to go into the block, because now it is correctly positioned in terms of depth, etc. It's still cleared off the block, and it has to now traverse so that the L slot that has been given here can be now fully machined. Okay. So the next position that we want really this tool to go with respect to the origin is about in the Y direction. So obviously the tool was somewhere here, which was corresponding to the 2.75 inches, and now this tool position has to come all the way to about this particular position, which is at a distance of 0.75 inches from the origin. Okay. So we can say that this comes, the Y changes from 2.75 absolute coordinates to 0.75, remaining other things remaining same, because it's at the same x axis of 1 inch, or represented earlier by x plus 1000 in the first step. So we now write the next step simply as N025 to be equal to Y 750. This is only the axis motion command that we are using, which means that the merely the controller moves the tool from the Y step of 2750 all the way to Y 750. Okay, so this is already defined at the predefined, we have already predefined the feed rate, etc. earlier. So obviously whatever the controller does in terms of motion between the point Y equal to 2750 and Y equal to 750, that motion is actually at the feed rate that has been specified, which is this 10 units per minute or inches per minute given earlier. Okay. So this becomes equal to then effectively cutting the vertical portion of the L slot. So I can write machines the vertical position or portion of the L slot. So once this machining is done, then obviously the tool now is at a new position located somewhere here, okay, and it is actually centered about this 0.75. So the other thing that we need to ascertain is that the tool goes in this direction from the current location 1.000 inches to 1.500 inches, okay, and so by traversing by another 1.500 inches. So because it's absolute dimension, the coordinate here really, the x coordinate here is 2.5 inches. Okay. So basically the other step that is involved here now is that asking the tool, N030 is the identifier number, asking the tool to now traverse from the position which is recently acquired, that is y750 x 1000 to an x value 2500. Okay. So automatically the axis motion command indicates that the tool has to feed forward in the x direction by about 1.5 inches, because earlier you had defined the position as 1.000 inches and now you are defining as x 2.500 inches. So therefore the relative difference is only 1.5 inches which is supposed to move. Okay, so therefore this ensures that the tool machines the horizontal portion of the L slot, and the only other thing that is remaining now is to sort of align the tool in a manner so that you can retract the tool away from the position that it has finished in the last step. So the tool finishes somewhere here and still rotating in the rotating condition, and you have to somehow now retrieve this away from the block or the L slot so that the tool doesn't do any further damage to the system. So the next step therefore can be that first of all, whatever depth had been provided to the tool in terms of going below the origin plane or the reference plane by 0.375 needs to be retracted back. So and in order to keep it safe, the best idea is to sort of take it again quarter inch over the surface so that it doesn't now touch with the surface, and you can take it easily to a direction or a location coordinate where it won't foul or interfere with any of the working block, etc. So therefore we give a machine command here N035, that is the identifier number corresponding to the 35th line, which we say that okay, now since all the machining is done, the Z needs to go back to 250. So the Z actually was earlier 250. If you remember, the tool was stationary at the start point above the workpiece surface by quarter of an inch, and then it came down to the plane and through the plane into minus 0.375 inches, which is on the other side of the plane containing the origin. And then now we are talking about again retracting it back from the after the cutting of the whole L slot has been over, retracting it back 2/4 of an inch above the machined surface. So that's why Z250. So this actually retracts the tool to 0.25 inches above the part surface, and then finally the tool needs to now get retracted to a point where it doesn't interfere with any of these workpiece features. So if we can go back from the origin to, let's say, some position somewhere here corresponding to about 1 inch in the negative y direction, and again 1 inch in the negative x direction, then obviously the tool is in the safe zone. So somewhere here the tool can be located. So the tool needs to get translated from here to here, and we can say that the 40th line of this program can give that command saying that take the x back to minus 1.000 and y back to minus 1.000, and this can be rapidly positioned again. So we can actually, because feed command is something that needs to be executed at the at the outset. Otherwise, the feed would be still the same 10, and then you can't have the rapid positioning access back again. So you can actually write G00 rapid position and X minus 1000 and Y minus 1000, and then you have to set the counter of the feed to 0 so that the feed can now be taken back by the G00 command. So this retracts the tool to a safe zone, the tool to a safe position, and then obviously you have to turn off the machine. So you can actually write another small instruction here saying M30, which sort of turns off all machine functions, and you can probably again insert a special character EOB here signifying the end of the block. So this whole block containing right about 9 steps gets started from the percentage line and then ends up all the way to the end of block. So you saw now that how we can actually do the real NC programming. So there are many processes in which you can validate what code you have written is really going to have a non-interfering toolpath and a continuous toolpath. So with Delcam, etc., there are certain packages which are there. You can actually develop autocodes and also try to simulate those autocodes on a platform where you can really estimate what is the toolpath like, what is the tool behavior like. So once there is a validation of this code, you can then feed into an NC system and start to do machining on workpieces. So with this, I would like to end this module. In probably the next module, we will start a little bit of issues related to lean manufacturing and Japanese production systems. Till then, have a good day from us here at NPTEL. Thank you.